Hi, my name is Dennis, developer advocate at the United Manufacturing Hub. In this video, we will delve deeper into the concept of protocol converters and especially how they are implemented in the UMH stack using Benthos. Now, in a previous video, as part of the UNS Basics series, I already explained the concept of protocol converters from a high level. So if you are not familiar with this concept, I would encourage you to rewatch the video that will be linked above me. So let's get started. The UMH uses Benthos to implement protocol converters. In essence, a protocol converter is necessary whenever the protocol of your source differs from MQTT, because our MQTT broker inside the unified namespace expects, of course, MQTT messages and not OPC UA or some obscure sensor protocol. So Benthos is essentially a data engineering tool that is used for stream processing, but can also apply transformations on the fly and more advanced things like multiplexing and so on. It's very nice because it's configured in YAML, which is both easy to read and to write for a human, and is version controllable. We will see in a moment how we can configure YAML to read data into the unified namespace using Benthos. Now, the UMH has adapted Benthos a little bit by making a custom extension called Benthos UMH, just to enable OPC UA reading, which is not possible in Benthos by default, and also to make Benthos play nicer with the UMH stack, making it easier to launch. And speaking of launching it, there are two ways how you can configure Benthos UMH inside the UMH stack. The first one is through the management console that we will see in this video. And the second one is by using Benthos UMH as a standalone Docker container. This process is more detailedly described in the README file on GitHub that you can read. It will be linked below the video as well. But in this video, we will limit ourselves to configuration through the management console. And to make the configuration a bit more lively to follow, we are going to implement a live connection to an MQTT simulator. And for this process, we will follow the guide about data acquisition and manipulation. And we are going to test a pre-configured data simulator, namely the MQTT one. Now, technically, we don't need a protocol converter for this because we are reading in MQTT data and writing it also in MQTT to the broker. So the protocol is the same for the source and the sink. Nevertheless, it presents a nice illustration of how Benthos UMH works in practice. So if we navigate down to the part where we are configuring the MQTT server, we are going to do that using the management console. So I can show you here, I have it open. I have one instance running on my local Proxmox installation in my network. And I have one instance of the UMH running, called the UMH. If you look at the component view, I don't have any protocol converters defined yet. So that will be our first step. We are going to add a device or an external service. I guess for the name, we can just call it our MQTT simulator. And then for the IP or the host name, you have to give the IP or host name of the MQTT simulator, which is listed here in this article. It's a pretty long name, so I'm going to copy it and paste it in this field. And as we are reading in data from MQTT, the port will be 1883. Now we can go ahead and test the connection to see if we manage to connect Benthos to this new network device, and the connection has been established. So now we can save this network device. And we see that the network view now shows this MQTT simulator connected to the UMH, and they are both green, so they are both online. However, if we look at the health, we see that we get a message that it's not yet configured. And this makes sense because we have just initialized this network device connected to the UMH, but we haven't actually written any YAML. So we haven't actually configured our Benthos UMH. This is what we will do in the next step. To do this, we will click on the play button. And as a protocol, we have two choices for Benthos UMH, OPC UA or a universal protocol converter, which basically means everything except OPC UA. Remember, OPC UA was added by Benthos UMH, which made it an extension of the normal Benthos open source tool. Right, so selecting the universal protocol converter, we click on next. And here we see that indeed you have to specify an input configuration YAML and a processor configuration YAML. In essence, the input will tell you where the data comes from, and the second YAML file will explain which data manipulations we want to apply to this input data. On the right, we see the supported protocols, and Benthos supports a lot of protocols coming from Azure to AWS, Kafka, MQTT, Pulsar, and so on. And we are going to rely on the UMH MQTT configuration, which is a sample that we can use to test the MQTT simulator. So by applying this sample, the code will be written here for us. And let's take a quick look. So we are going to make a TCP connection to the MQTT simulator by the host name we saw earlier from the article 3. And we're going to read two values, well, from two topics, for the temperature and the humidity. That we can leave as default. The processing will be as follows. We're essentially defining some variables that will make up the topic name on the broker, adhering to the ISA 95 part 2 specification. So we have an enterprise, site, area, line, and so on. And by means of practice, I will change the name of the enterprise so we can then inspect it later in the tag browser. I will call it video Benthos test. Right. A second thing I will do is we are essentially reading temperature and humidity data, which should be floating points. So the final value should be a number and not a string. So I'm going to replace the string by a number. Right, so now we have configured Benthos by editing the YAML files. We can save this configuration and wait until it is deployed. So the deployment is now in progress. It can take a number of iterations, but once this is complete, we will be able to inspect the health of our protocol converter in the component view, and in a later step, we will also check the data in the tag browser. So let's now navigate to the protocol converters. Now we see that we get a reading for the health. It's healthy. We get about one message every 2 seconds. And let's now inspect the data in the tag browser. So indeed, here I see my video Benthos test enterprise that we just created. If we navigate down the hierarchy all the way to the historian, we see that under the tag grouping weather, we indeed have two humidity values, which are floating points and are updated in real time. So here we see the humidity, and we get a similar graph for the temperature, again read in real time. So I think the point here was really to show how trivial it is to integrate MQTT sources or other sources in different protocols using Benthos UMH with the management console. A lot of the logic about the connections is hidden away from us, which makes the whole process very smooth. Let's finally look at an alternative. You may be familiar with Node-RED. In a previous video that I can link here above me, we saw how to integrate data from the MQTT simulator into the broker using Node-RED flows. And as you can see, we did the same thing now using Benthos UMH. So when would you use one versus the other? Personally, I like Node-RED a lot in the sense that it's a graphical way of coding. You drag and drop blocks and connect them with lines, which gives you a very nice visual representation. You can also export it to JSON to have it saved in your version control system. But Benthos UMH is without a doubt the more stable option, better suited for production workloads that are rather big. The UMH has tested and has concluded that Benthos is more stable than Node-RED under large workloads. But I would encourage you to give both tools a chance and make the decision for yourself. Right, as always, thank you for watching, and I will see you in the next video.